How's it going, everybody? Welcome to my channel. Today we have a very good problem for you guys called merge k sorted list. So this is a very good problem, so make sure you pay close attention to the problem statement, right? So it says we're given an array of k linked lists, right? Okay. Each linked list is sorted in ascending order, right? So okay, so merge all the linked lists into one sorted linked list, right? So we have a bunch of linked lists, and we want it to be sorted in one sorted linked list, right? And returning. Okay, so pretty simple problem statement, right? So we have a bunch of linked lists, right? So it's an array of linked lists, right? So and then we need to combine them, right? Into one single linked list and then return it, right? So this example is gonna help clarify the ask. So you can see here we have 1, 4, 5, right? And then we have 1, 3, so a bunch of linked lists, right? So each of them is a separate linked list. That's one linked list, another linked list, another linked list here, right? So that's kind of what it is, right? Then as you can see for the output, right, we have one big list, right, that contains all the values, right, from all those different linked lists, right? That's why it's called a merge linked list, right? So it's kind of what the ask is, right? So we're given this, right, after merging them, right? So this is, they helped us to visualize this, right? This is a very good on their part. And after merging them, we can get that, right? Then we have an empty list. We already know nothing, we do nothing, right? Yeah, so just like that, that's how it is, right? Pretty simple to understand, right? So how do we go ahead and solve this particular problem, right? A straightforward way, right, we could come up with is to simply just add all of, pretty much go through every list, right? And add them to, some sort of like an array list, right? Right? So we add them to an array list, right? Each individual node. So we go to this list, we add all the values to that array list, right? And then we go through this one as well, right? We add them to a particular list, right? Not a linked list, but array list, right? And then after we do that, we simply, after we add all of the different numbers, right? Nodes, right, values into this, right? We go ahead and call the sort function in our whatever library language you're using, right? Call the sort function, right? And then that should take care of it, actually, right? It will be analog again, but it wouldn't be too bad, right? It's a pretty good start, pretty good start into the right direction, right? So interview setting, that'll probably be a good way to start off and pretty much say, right? So, but as you can see, it can't be that easy, right? We're gonna have to be a little bit more clever than that. All right, so we have to bring down the time complexity if possible, right? So that's what I'm gonna show you guys. There's a pretty particular approach that we're gonna take, right? That involves using a heap, right? Heap, pretty much, I'll tell you exactly what we needed, right? So what we could do, right, to bring down the time complexity, right, is to add each head of each list, right, into some sort of a heap, right? So the heap will help us in being able to get the minimum number from each list, right? So the lists are sorted themselves, right? So that's kind of why we can use this property, right? So we add the head of each list, right? The head of each list is the smallest element of each list, right? So we add the head of each element of each list to a heap, right? And then at each time, right, we could ask the heap, right? Because the heap is gonna organize the stuff in a sorted order, right? Right? So the main heap is gonna have the smallest element at the top, right? So we get the smallest element and we start creating our list, right? So we keep going as we go, right? And it's dynamic that way, that each time we can easily ask the heap, right, for the smallest number out of all the numbers, right? Right? So if we know the smallest head value, right, across all those lists, right, but that's pretty much the smallest number in the lists at that particular time, right? The smallest number, right? So that's kind of how we do it, right? So the head, we add each head, right? And as we go through, right, we ask for the smallest one, right? We use it, we put it into an output list, right? And then what we're gonna do, we're gonna see if there are other numbers in the list, right? There are other numbers, then we go ahead and put the rest of the list, right? But the next node, right, is gonna become pretty much act as the head, right, for that list, right? Because that's where the cursor would be, right? Because we've already taken care of that particular thing, right? We move on to the next one. So I'm gonna do a quick walkthrough with you guys, so hopefully it makes sense, right? So it's gonna make a lot more sense when I do a quick walkthrough with you guys, right? and the code will be even simpler than that. So yeah, guys, so like I was saying earlier, right? So this is the walkthrough that we're gonna do really quickly. So this is all the different linked lists that we have, right? So this is the first linked list, second one, and the third one, right? In our list that we have here, right? Okay, so like we said, we'll be adding each head, right, to our heap, right? Because the heap is gonna help us in capturing the smallest value each time, right? And if we know the smallest head value, right, smallest head here across all those lists, right, then we pretty much know the smallest number across, all those different nodes, right? At a particular time, right? So this is kind of the flexibility that the heap gives us, right? So the list themselves, each individual list is already sorted, right? And we know that the thing at the whatever's at the front, right, is the smallest value for that particular list, right? And that's why when if we know the smallest value, the head value across all the different lists, right, we can be confident that then that's the smallest value, and then we could use that value and build our output list, right? So enough talking, let's go through a quick walkthrough, right? So we go ahead and we will add one, right? Which is the first one here that I'm adding, right? Add one, insert. We'll add this other one here that's here, right? This one here, boom. This is how it looks so far, right? And then I'll add the two here, right? Okay. So I've added it. It looks, pretty good so far, right? So now we can start building our list, right? So what we normally do in those type of problems, guys, we normally so we need to build it, right? So we're gonna have a dummy node, right? That's gonna pretty much chill at the front, right? So that we can have access to it, right? So that we can return the head of our output list, right? This is a very standard way of doing this type of problems when we want to build like a list, right? Okay, so we call this a dummy node, right? Yeah, it's kind of hard to write here, but it doesn't matter. So yeah, and then we're gonna have a curve variable, right? That will be, pretty much help us to build it as we go along, right? A curve variable, right? Build the output list, right? This is what can help us to iterate and to connect nodes and things like that, right? So it starts off here, right? And then what we're gonna do is to get our first node, right? So our first node, smallest one, we'll pick the first one from the first list, right? Then we go ahead and get that one here, right? Boom, output list. So cur, that next points to this one, right? Okay, right? Which is, this is our list that we're building, okay? All right, so we point to this one, right? And then what we're gonna do, we're gonna pretty much move this guy now, right, to here, right? So let me draw an arrow to make it even straightforward, right? So it points to here, right? So now what we're gonna do, right? So are we done? So we need to remove that. So we remove the smallest element. So this is what I meant to say. So remove the small element, right? Okay. So this is how it would look now, right? So we put this in there, right? So we have our first node, which is one, right? Which is the first value, right? And right. So now what's next for us is so we still have numbers in the first list, right? We still have numbers to be, added. So we can't just ignore them, right? We need to account for them as well. So what we're going to do is to add the next value, right? If there's still values to be added, right, from that list, so we go ahead and add it, right? So the next value, right? So this guy, we're not accounting for it no more, right? We've already taken into account, right? So now the thing at the front now is 4, right? Because we're going to be adding 4 to the list, right? So that's how it looks now, right? So now we call on the smallest one. The smallest across 4, 1, and 2, right, is obviously 1, right? So we go ahead and get the one here. Okay, looks good so far. All right, so once we take care of this one, right, so we need to add the 3 because there's still numbers from that list, right? All right, there's still 3, right? So now we need to add the 3 to take that into account, right? It's not null, right? So now we have this one, right? So now we need to no, I meant to do skip back, right? So I skip back. So pretty much so I need to remove the smallest one, right? So remove the smallest one, and then we add the 3 guys, right? This is how the algorithm is going to work, right? So insert. So now it's, that's our list now, what we have in the heap, right? We have 4, 3, 2, right? Which is exactly what we have here, guys, right? So now we go ahead and get the smallest element. The smallest element is 2, right? So out of 4, 3, 2, 2 is the smallest one. So we remove the smallest, right? Get this out of here. So now 6, there's still nodes in that list. So we go ahead and add it, right? Add 6 to it. Insert, all right? So let's add the 2, okay? Let's move cur forward because that's what's helping us in building it, right? Okay. So now we have, out of, 4, 3, and 6, the smallest one's 3, right? So that's why it's at the top, right? This is what the heap is so useful, guys, right? So I just want to reiterate that, right? So we remove the smallest one, right? Okay. And we create our node, right? Point to 3 now, right? That's bad. Let me redo it. There we go. We had the 3, so it looks good so far. We're almost there. So there's still nodes in 3, right, in that list, right? So we need to add it, right? So we're going to be adding 4 to it, right? Okay. So we took care of that 3, right? Perfect, right? So now out of 4, 4, and 6, right, the smallest one is 4, right? So let's remove that 4, right? Remove the smallest one. You guys get the gist by now, hopefully. So let me see. All right, so let me just yeah. So we remove the 4, which is the first 4, by the way. Right? Doesn't matter. Right? Still gonna work out the same if you get the other 4. So we take care of that 4, right? There's still values in that list, so we need to add the 5. Right? Let's add it real quick. Okay, 5. We insert 5. Right? The smallest value is 4 again. Right? Out of 5, 4, and 6. Right? 4 is the smallest value, right? And yeah, each time we were supposed to move cur, right? Because every time, right? Okay. So now out of 5, so we go ahead and create our 4. Okay. Then there's no more values, so nothing gets added, right? But we would need to remove it. So now in the list, only 5 and 6 is left, right? So out of, so we need to move that forward each time right after adding, okay? So that we could point to the next new node, right? And then what we're gonna do, we do that's the 5, because that's the smallest one, and then the 6, right? Remove the smallest, right? And then the 6, remove the smallest, right? And then that's how 5 points to 6, points to 6, right? And that's why at the end we return this guy, right? Which is dummy.next, which is exactly what we have here at 1, 1, right? 2, 3, 4, 4, 5, 6. We confirm that the algorithm indeed does work. Indeed does work, right? So let's quickly go into the code. It'll make even more sense, right? So let's go, guys. So yeah, so let's quickly do the code real quick. It'll be very, very simple, guys, right? So we have the RDQ, and we're gonna listen note type, right? And we're gonna have a heap, right? To main heap. Okay. And then right, what's next for us is to write our custom comparator, right? That we're gonna write, right? So we're gonna use the lambda function, right? Keep it simple, elegant, right? So we're gonna compare them based on their values, right? Sorted order, right? Okay. So what's next for us is to go ahead, right? Like we said, to add the head, right? I've told you guys the reason why we are adding the head, right? Because it's the smallest values across all the different lists that we have, right? So all the different heads, right? Then the list. We go ahead if, right? The head is not null, right? We go ahead and just add it to our heap size, right? Add the head to our heap. Okay. Okay. After adding that, right, then we can start with our algorithm, right? So we have a dummy node, right? To show in the front so that we can just to dummy that next to return our result, right? Then we're gonna have a cur variable that's gonna help us to add numbers and to iterate through the list, right? Go to dummy, right? And then we're gonna have this while loop, right? Pretty simple. It's pretty standard how we go about this. Is empty, so until it's not empty, right? We're gonna be in this loop, so we're gonna take one node at a time, right? So head node, we get it out the heap, right? And see exactly what was doing the walkthrough. So we get it out by heap depot, right? As you saw in the visualization, right? So we took the one node out. And then what we're gonna do, right? What's next, right? Just to point cur, right? Cur that next, point to whatever this node is, right? Because that's the smallest value across all those lists. right? Okay. And doing it that way ensures that the list is going to be sorted, right? So after we do that, right, what was the next step that we did? We go ahead and if there are still values, right, for that particular list, right, if there's still values to be added, then we go ahead and add it, right? So we add the clear that next, right? No, I meant to do makes no sense. I meant to do node, that particular node, right, from that list, right? Add that next, right? That next node from that, right? Because there's still nodes in that particular list, right? Okay, and then what's next for us, guys, right? Is to simply do cure, go to cure that next to move forward now, right? Not much to do after that, right? And then after that, we simply return, right, the dummy that next, right? So we go ahead and added all the head nodes, right, to of each individual list, right, to the heap, right? And then we go ahead and build our list, one node at a time until we at the end, right? So the removing and adding, right, is log k, right? It's gonna cost log k, right? And then we do that n times, right? So that's what time complexity is, n log k, guys, right? It's a very good way of doing this problem. So let's press the run code, see if we pass small test cases. Awesome. Let's press submit, see if we pass all the test cases. Looks like we did on the first try, guys, right? If you guys found this very useful, right, let me know in the comment section. If you guys didn't get any value from this, also let me know in the comment section to help me improve so that I can get better for you guys. So if you guys liked it, let me know as well, right? If you're new here, subscribe, because we'll be doing a lot of other videos just like this one. So I want to thank you guys for watching, and I'll see you guys in the next video.